Hi there, welcome back to the formulaic approach. Now in this video, we want to talk about trigonometry. Now, the basic idea is to show you trig identities and proofs and special angles. Now, however, if you want me to take it from the scratch of measurements, of angles, of the triangles, types of systems of measuring angles, the centigesimal, sexagesimal, centesimal, etc. All those systems, the measurement of triangle itself overall, the use of trigonometry, trig functions, blah 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 like that. If you want me to take it from the scratch, from O level to A level, then let me know in the comment section. I'm going to do that. But I just want to do this short video. It's not going to be very short, but at least it's just going to show you a few things that you can. For those of you that already know basic trig, you will find this handy as well. Exactly. So now, what are the trig identities? First, you have to know what trigonometry means. The word trigono is the word from trigon. Trigon, tri means three. Gon means sides. So then the word meter is from the word metria, which means measurement, right? So what does this mean? It means measurement of three-sided polygon, right? So what's a three-sided polygon? That's a triangle. In fact, the word trigon is another English word for triangle. Let me check if this thing is recording. Okay. So the word triangle is also called trigon. So basically, we are showing the measurement of triangles. All right. Now, we know that there are different types of triangle. The one that is very pertinent to this work I want to show you is the one that is called the right angle triangle. How did I get it? If I have any type of triangle that whether it's isosceles, scaling, or what's it called now, and I'm able to split it with a straight line like this. Okay, whether this one now, for example, is scaling, this side is not equal to this side, and it's not equal to this side. So if I'm able to divide it like this, I'll form what is called a right angle here. Okay, so if I separate it, what I'll have is on one side, on this side alone, I'll have this. Okay, and this is the triangle I want to talk about. So this is the right angle triangle. So it turns out that what we do in trigonometry is to measure the relationship between the sides and the angles of the triangle. That's one of the major things that we do. Is that okay? So now what is this side? These sides of this right angle triangle has special names. Those names do not appertain with the bigger triangle that you see here. Okay? So this triangle here, the right angle guy, this long side is called hypotenuse. You probably already know that. If I choose this side as my angle, theta, then the side that is facing is called the opposite. Okay? Opposite. And the adjacent is the side that is beside the angle. Exactly. So this is the adjacent, this is hypotenuse, this is opposite. I mean, what that means is that if I change this angle to this place here, this becomes the opposite. So the part opposite and adjacent, they switch places depending on the angle that is given. The place where the angle is given. But hypotenuse never switch places. Hypotenuse is the longest side, the slant height. Is that clear? Now it turns out that Pythagorean will work on this in the, I think, 16th century, and we'll find out that Pythagoras theorem. So it will postulate the fact that the square, hypotenuse square, is equal to opposite squared plus adjacent squared. Now you can try it. It's very simple. What he said was that if I have a triangle like this, if you make a square, let's say this length is actually, let's say as it is now, like this, is about 10 centimeters. Now this one here is about 15 centimeters, and this one is about maybe 12 centimeters. Now what you want to do is this. What Pythagorean theorem is saying is that make a square that is 10 centimeters on this side. Make another square that is 12 centimeters. 12 centimeters by 12 centimeters by 12 centimeters on this side. That when you calculate the area of this square plus the area of this square, that it's going to be equal to the square of this side, the square that you can make out of this side. That's what his postulate is actually talking about. Exactly, and if you look at it, you can see that the square of this side and this side, if you add them together, looks like will give us this. Is that okay? You can try it at home. Use scaled drawings, and you get it. So that is his idea, that hypotenuse square is equal to opposite square plus the adjacent square. But before we begin to use this, I also want to show you some trig functions. Now, some trig functions that also exist is what we use to tell the relationship between all these sides and their angles. It turns out that this angle, that the sine of that angle is actually equal to the ratio of the opposite over the hypotenuse. So let me just use O over H. So that's sine of an angle, of that angle. The cosine of that angle is the adjacent over hypotenuse. That's the relationship. Then there is the tangent of the angle. That is the opposite over the adjacent. Now, these are the functions that hold true that we know. Okay? These are the fundamental ones rather. So we use the mnemonic SO, CA, TOA to remember. Is that clear? So, sine equal to opposite over hypotenuse, cos theta equal to adjacent over hypotenuse, tan theta equal to opposite over adjacent. Alright. So it will turn out that you will see from here that if you take the ratio of sine of an angle to cosine of that angle, it will be equal to O over H over A over H. That becomes O over H divided by A over H divided by A over H. So we have O over H times H over O. H over A rather. H takes care of E, and then we have O over A. Now what is A over E? A over A. O over A, opposite over adjacent is tan theta. So we have found out that tangent of theta, rather than just write opposite over adjacent, is actually equal to the ratio of sine of an angle over the cosine of that angle. So we have proven something just now. Now, another thing is that we now have some other special functions. Okay, so I'm going to clean this and write it later. Now, some other special functions that you have to know include the following. Now, if we take the inverse of this, that is, if we take 1 over this angle, that is 1 over sine theta. Now, that one is called the cosecant of an angle. So the cosecant of an angle is 1 over sine theta, which will be equal to what? Hypotenuse over opposite. So just invert this, and then you have that. Now it will turn out that what we call 1 over the cosine of an angle is also equal to secant. It's called the secant of an angle, sec theta. So here for this cosec, I might write CSC theta is the same, okay? Alright. So inverse of cos, that is the hypotenuse over adjacent. Exactly, that's what we call secant of an angle. Then 1 over tangent of an angle, 1 over tan theta, is equal to the cotangent of that angle. And what would that be? That would be the inverse, the reverse, which is A over O, or cos theta over sine theta. Since we just found that sine theta over cos theta is tan theta. So if you reverse that, it's going to be what? Cotangent. Okay? This one means cosecant, cosecant. This one means secant, and this one means cotangent. Is that clear? Now that we have all of this, now let's go on to using those things. Pythagoras theorem to check for some identities, to check for some fine identities. Now, we know that Pythagoras theorem, so let me just put PT, states that hypotenuse squared is equal to opposite squared plus adjacent squared. From here, I could just choose, for example, to divide with this one. If I divide everybody with h squared, for example, if I divide everybody with h squared, what am I going to have here? This takes care of this, and I have 1 is equal to opposite over hypotenuse all squared, right? Plus adjacent over hypotenuse all squared. Okay? Now, what is opposite over hypotenuse? It turns out to be what? Sine theta. Opposite over hypotenuse is sine of theta. So 1 on this side is equal to what? Sine theta all squared plus adjacent over hypotenuse is cos theta. So we have cos theta all squared as well. So it turns out that if I bring that guy to that side, it becomes that sine. Now this square, we normally put it on this function rather than the theta. So it becomes sine squared of theta plus cosine squared of theta is equal to 1. So this is the first trig identity that you need to know. Is it clear? From here, I can find other things. I will find out that the sine squared of theta is also equal to 1 minus cos squared theta, and so this will be equation 2, and that the cosine squared of theta is equal to 1 minus sine squared theta. This is equation 3. We have been able to find 3 identities from here. Is that clear? Now, furthermore, what if from that same equation that h squared equal to o squared plus a squared, what if I decide to divide through by o squared? So I divide here by o squared, divide o squared itself by o squared, divide a squared by o squared. This side will turn to 1, right? Then here we're going to have h over o all squared is equal to 1 plus a over o all squared. Now something else has taken place again here. H over o, we got it to be what? Inverse of sine, right? Which we call what? Cosecant. So we have cosecant theta all squared, okay, is equal to cosec of CSC, okay, equal to 1 plus a over o. What is a over o? Cotangent. So we call that cot theta all squared. So it turns out that we just found another identity that says that cosecant squared theta is equal to 1 plus cot squared theta. So let's call this equation 4. So from here also we will find out that cosecant squared theta minus cot squared theta is actually equal to 1. This is equation 5. You also find out from here that cot squared theta, that we can also do the fact that cosec squared theta, okay, I don't want to change it, flip it. So cosec theta will be, minus 1 will be equal to cot squared theta. So this is equation 6. Are you seeing what we're doing? All right. Now all of these equations that we're deriving are going to be useful soon. Is that clear? Because we're going to use them to prove other identities. Now watch this, watch this. What if I now decide, which one have we not used here? We have not used a. So h squared is equal to o squared plus a squared. What if we decide to divide through by a squared? We divide through by a squared here, over a squared here. What are we going to have? This side will give us 1 again, right? So from here we have hypotenuse over adjacent, all squared is equal to opposite over adjacent, all squared plus 1. Now what is hypotenuse over adjacent? That is sec, right? Sec theta. So we have sec squared theta, I just want to write it directly, will be equal to O over A. That is what? Tan theta, O over A, right? So tan squared theta plus 1. This becomes our next equation, 7. Then from here we will also find out that sec squared theta minus tan squared theta is actually equal to 1. By the time you bring this guy here, right? This is equation 8. Now we also find out from here that sec squared theta minus 1 is actually equal to tan squared theta. This is equation 9. Is it clear? So we'll be able to derive 9 identities from here. Now, keep all of this in mind because I want to clean the board now and I'm going to be using them. I'm going to need them. But before we do that, now, there is one equation that I want to show you. There are some equations I want to show you here now. Now, those equations, let me bring them here. I'm going to prove them if you want me to in the video where I will do an extensive teaching on it. I can prove them for you. But because of the content of this video, I'll just give you those formulas, okay? The formula for addition of angles, addition of sine of angles and addition of cosine of angles. So it turns out that it was found out that sine of a particular angle A plus angle B is actually equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Is it clear? This formula holds true. All right. So in this case here, what if I have the same values here? What if I have sine of A plus itself A? You know this is the same as saying sine 2A, right? So it's going to be, our range is to be sine of A cos B, cos A plus, I'll just do the same thing, cosine of A cosine of A, sine A. Now what do you see? You are seeing sine A cos A together, right? So it becomes 2 of this. We are seeing sine A cos A twice. So it becomes 2 sine A cos A. So this holds true also. This holds true. Now, one thing is that the sine of a negative angle, for example, sine of minus A, for example, is equal to the sine negative of the sine of A. So if this is the case, then we know that if I change this formula, this guy to minus, such that I have sine of A minus B, it will be the same thing that I will have the sine of A cos B minus the cosine of A sine B. Alright, so this holds true. Okay, so now we've been able to find another identity here. You know, from here we have been able to find this identity 10. Alright. Now, the next thing you should know is for cosine. Now, cosine of A plus B actually was found to be sine of cosine first. Cosine of A dot cosine of B. Now when it's plus, it will be minus. Okay? When it's plus, it will be minus. So it was found that this minus sine of A dot sine of B. So if this be the case, then we are saying that the cosine of, if I have an angle double itself, double of an angle, such that this becomes cosine of 2A, right? This will be cosine of A dot cosine of A times cosine of A. That becomes cosine squared A. Cosine A times cosine A becomes what? Cos squared A, right? Minus sine A sine A, because it's not B, it's A, right? So minus sine squared A. Is this clear? Good. So cos 2A equal to cos squared A minus sine squared A. But if you notice, we have come across this before, right? We have come across this something squared, cos squared and sine squared before. So if I want to write cos 2A in terms of cos, so let's write cos 2A in terms of cos. You know this 11 now, these are 11th identity. If I want to write cos 2A in terms of cos, I know that sine squared is 1 minus cos squared theta. So I can say that cos squared A minus, open bracket, what is sine squared A? Sine squared A will be 1 minus cos squared A, given that theta is A. I mean, it's an angle, so it's just a change of value. Cos squared A. Is that clear now? So if this be the case, then we have that cos 2A becomes cos squared A minus 1 plus cos squared A. So what does this tell you? Cos squared A plus cos squared A. So cos 2A becomes cos squared A plus cos squared A will give us what? 2 cos squared A minus 1. So this is another identity. So cos 2A can either be written like this or be written like this. Or the third way we can write it is writing in terms of sine. If you want to write it in terms of sine from here, we'll just substitute for this guy. So that from there, cos 2A will become, remember that cos squared A will be 1 minus sine squared theta, 1 minus sine squared A. So 1 minus sine squared A minus sine squared A. Okay? So we have that cos 2A becomes 1 minus, into bracket, sine squared A plus sine squared A. You know, if you open the bracket with minus, it will give you back this minus, right? So this plus this give you 2 sine squared A. So cos 2A is equal to 1 minus 2 sine squared A. This is another identity, identity 13. So what does this tell you? That cos 2A can either be 2 cos squared A minus 1 or 1 minus 2 sine squared A. Is that clear? Good. So these are some of the identities that we probably need. What if we need to do cos 3A? I'll do that in the other class. If you request for the video, I'm going to do an extensive study. I'm going to do more derivations. Now let's deal with Let's do now. Write this all of this down so that by the time we need them, by the time we want to solve, you can be referring back to them. So I want to clean this part now. So what do we need to talk about now? We have not talked about tangent. So let's quickly talk about tan before we solve questions. So now we'll solve questions for proving. Now, if I have tan A plus B, what would this be? Remember that we have proven that tangent of an angle is equal to the sine of that angle, which is in this case A plus B, over the cosine of that angle, which is in this case A plus B. Is it clear? Good. So from here, we know that sine A plus B is the same as sine, I didn't show you cosine of minus, of A minus B. Cos A minus B, let me quickly write it here. It turns out that the cosine of a negative answer, the cosine of a negative value is actually the cosine of that value. That is, negative does not appear again for cosine. The cosine of an angle, of negative of an angle, is equal to the positive of the cosine of that angle. But negative of this change to negative of the sine. It's still the same for sine, but for cosine it changes. So what do you see here? That the sine of A plus B comes back to this place. A cos B plus cos A sine B. So if that be the case, over cosine of A plus B becomes cos A cos B minus sine A sine B. Now let me show you something interesting that we're going to do here. How can we express this so that it comes back to tan? How can we express it? This is what I will do. I will divide all the numerator and all the denominator by, how can I make it to be tan? You know tangent is sine over cos. So which of these values which of these expressions can I use to divide everybody that can make me have sine over cos ratio all the time? It is this guy. If I use this guy to divide this guy, you see what will happen. See what will happen. If I use this guy to divide everybody, it will become sine A cos B all over cos A cos B plus cos A sine B all over the same guy, cos A cos B, then all over, because this is everything on top, all over this itself, cos A cos B over cos A cos B. What I'm doing is, for those that are already confused, I'm using this guy to divide everybody, okay? Then minus sine A sine B all over cos A cos B. If this is the case, therefore, cos B cancels out. Cos A here cancels out. Here, cos A, cos B, everybody cancels out. Here, nothing cancels out because it's sine A, so nothing cancels out there. So what are we going to be left with? Let me clean just this part here so that the identities will remain. So I'm going to bring it here. This becomes, what do we have on top left? We have sine A over cos A left there. Plus here, what do we have? We have sine B over cos B left there. Then all over here, what do we have left? Nothing, 1. Everything has cos, so it's 1 that is left there. Minus, here, what do we have? Let's separate here. We have sine A over cos A times sine B over cos B. If this be the case, then we are saying that what is sine A over cos A? That is tan A. Plus, what is sine B over cos B? That is tan B. All over, what is 1, then minus, what is sine A over cos A? That is again tan A. What is sine over cos for B? Will also be times what? Tan B. So this is the formula for tan A plus B of that sum of an angle, sum of angles like that. Now, what if we are now told to do the tan A for identical angles, A plus A now? So using this formula, it will simply become tan A plus, here A is B, or B is A. So we have plus tan A again. All over here we have 1 minus tan A, tan B. So tan B here is going to be A again. So this becomes, you know that tan A plus A means tan 2A, right? So tan 2A will become tan A plus tan A, 2 tan A. So that will be 2 tan A over 1 minus tan A times tan A, tan squared A. So this is the proof for tan 2A. Now, I don't want to go further because I've told you if you actually request it, I'll shoot a longer video on this. So these are the, so write all of this down. These are the identities that we need to prove the following, to prove whatever we want to prove, okay? And they hold true for every case, for every angle, exactly. So now, there are other identities that I'm supposed to prove, that I'm supposed to show you, because I can't, if you request for the longer video, I'm going to show you how these formulas were gotten, these ones here, how they were gotten. I'll show you. All right. So let me write questions on the board. All right, so I'll be proving only these 6 identities. I'll be proving only these 6. Now, if you want more or you want me to go, like I've said, in depth, do well to subscribe to the channel and let me know. Please subscribe to the channel. God bless you as you do so. And share the video with your friends, of course. So if you now need more questions, if you have understood what I've done, you need more questions, also reach out to me. You can reach out to me on the WhatsApp number +2349021416307. Right, now watch. You see this number 1. Now I want to prove it. We have the square root of 1 minus cos squared theta over cos theta is equal to tan theta. Now, very simply, what you do is compare these equations. What you want to do is make this the left side of the equation, this is the right hand side of the equation. What you want to do is try to make this equal to this. Now, you can make this equal to this, but it will be harder to make this equal to this. It's harder to do that. It's easier to make this equal to this. So we choose the complex one to break it down, to simplify, right? So in this case, remember that we found an identity that says that sine squared theta is actually 1 minus cos squared theta. If that's the case, I'll remove this guy here and put this guy. That becomes root of sine squared theta over what we have here is cos theta. Now by the time I solve this further, what's the square root of this? So basically what we are doing, what this means is the square root of sine theta all squared. So square cancels square root over cos theta. So what do you have? What you have left is sine theta over cos theta, which is equal to what? Tan theta. Do you see that now? So we'll be able to make it. So now you see that the left hand side is equal to the right hand side. Do you understand now? So we have been able to prove that. Now number 2. Number 2. 1 plus 1 minus sine theta, 1 plus sine theta all over sine squared theta should be equal to cot squared theta. Let's see if that is true. We'll first open this bracket. This is the more complex one. We'll simplify it. Let's open the bracket. 1 times 1 is 1. I mean, if you know difference of 2 squares, you remember that a plus b times a minus b is the same as a squared minus b squared, right? So in this case, we'll follow this. A minus b, a plus b. Is it clear? So just follow. We'll square the first guy. 1 squared is 1 minus the second guy squared. That is sine squared theta all over sine squared theta. That this thing I did here helps me not to be going 1 times this, 1 times this, 1 time. You understand? So now from here, we know that this here is equal to this here, 1 minus sine squared theta. We know from here, 1 minus sine squared theta will be cos squared theta, right? So that will be cos squared theta over sine squared theta. And what are we getting at? This, okay. Remember that cos over sine. Remember that cos theta over sine theta is cot, right? So if you square it, then it becomes cot squared theta. So proven. So we put QED, right? you know the full meaning of QED? Put it in the comment section. QED. I had someone who said it means quite easily done. Okay, so anyways, put it in the comment section. All right, so number three is equal to, it says that sec theta minus tan theta, sec theta plus tan theta is equal to 1. So you can see again that thing repeating itself. Minus a minus b, sec theta minus tan theta, a plus b, sec theta plus a minus b, sec theta minus tan theta, a plus b, sec theta plus tan theta. So what does that give you? To give you square of the first guy minus square of the second guy. We call it difference of two squares. So square of the first guy minus square of the second guy is equal to 1. And this holds true. And this one is not hard at all. So it's very true because remember we did something like that said that sec square theta is equal to 1 plus tan square theta. We already saw this trig identity in our maybe the number 8. This will be like number 8 or number 6. I know it because I've worked with it before, so in case you are saying, how did I know it? I mean, we just derived it, so I know the order in which I normally derive it. Then number 4 says that sine, don't worry, I might solve all these questions here. If you need questions, just text me, I'm going to send you a question. Sine square theta minus sine to the 4th of theta equal to cos squared theta minus cos to the 4th of theta. Now, very simple. What we'll do is we can either express this one in terms of to look like this, such that we'll have, now remember that, let's first express this as sine square theta minus, this one becomes sine square theta all squared. Is this clear? So, raised to power 4, okay? So what I want to do is to write it in terms of cos. Remember that sine square theta is 1 minus cos square theta, so we write it like that, 1 minus cos squared theta, then minus sine squared theta again, that is 1 minus cos squared theta, all squared. So if this be the case, we have 1 minus cos squared theta minus, open square bracket, to square a number like this, square the first guy becomes 1 squared minus 2 times 1 times this, that becomes 2 times 1, 2 times this, minus 2 cos squared theta, then plus the square of this. If you square minus cos squared theta, it becomes cos raised to power 4 theta, cos quadrupled theta. So we have 1 minus cos squared theta minus 1 squared, that's 1, minus times this plus 2 cos squared theta minus times this minus cos to the 4th theta. Okay, so from here, 1 takes care of minus 1 minus 1, 0, right? So let's write this one positive first. 2 cos squared theta minus, before I write this one, minus cos squared theta. Okay, then minus cos to the 4th theta. Now looking at this, I have 2 cos squared theta minus 1 cos squared theta. That was 1 cos squared theta minus cos 4th to the cos 4th theta. So you see? QED. Yeah, we usually use QED to end an expression that we are proving. Okay? Right. So now number 5. Number 5 says that 1 over sec x tan x is equal to cosec x minus sine x. Okay, sine x. Now very easily, you find out that we can reduce this to this, right? It's easier to do that. Now what are we going to do? Let's break this guy down. Remember that sec x is 1 over cos x, right? So this becomes, now don't let it confuse you. Students often get confused. They think because this one is starting with s, that it should be 1 over sine. No. Cosec is 1 over sine. Sec is 1 over cos. So here we have 1 over here, 1 over cos x, then multiplied by here. Tan x is sine x over cos x. We always write the function in terms of whatever we are given. So in case we are confused as to why I'm using theta in some places, x in some places, it's the same. It's just angles. We're using algebra to represent the angles. So yeah, let's take, okay, it's not we'll multiply, right? So it's 1 over, this times this gives us sine x over cos x times cos x. That's cos squared x. Now what does this become? Inverse of sine over cos squared x. Cos squared x will come up. That becomes cos squared x over sine x. So from here, what do you have? What we have is, if we express this in full, this is the same as cos x multiplied by cos x over sine x. Now, okay, we are not yet done. I have not gotten what we want to get. 1 over this. Okay. You know that this times this, 1 over cos, yes, sine over cos. This times this cos squared theta. So 1 divided, yes. 1 divided by this. That will be 1 over 1 times cos over sine now, yes. So from here, let's rewrite this like this. Let's write it like this. That cos squared x will be equal to, remember that cos squared x is equal to 1 minus sine squared x, right? So I can rewrite this as 1 minus sine squared x, 1 minus sine squared x over sine x. So if that is the case, I can split this. Let me split it. It will become 1 itself over sine x minus sine squared x over sine x. This one will take care of 1. Okay, so 1 over sine x is cosec x minus, here cancel 1, it remains sine x. So it has been proven. QED. Alright. So the next one, which is the last one, is this one. This one. So I'll clean these questions and quickly solve it there. So it says that sine theta over 1 plus cos theta plus 1 plus sine theta over sine theta. We should prove that it is equal to 2 cosec theta. Alright, this is also easy to prove. Now, how do we do this? Let's take LCM. What will be the LCM here? The LCM here will be LCD, lowest common denominator. LCD will be sine theta times everything here, 1 plus cos theta. So if that be the case, this in this will remain sine theta, right? This cuts this, it remains sine theta. Sine theta times sine theta, that is sine squared theta plus this entire thing in this. Sine theta cancels sine theta, it remains this. So that will be 1 plus sine theta multiplied by this that is remaining, 1 plus cos theta. Okay? Now, we have that sine squared theta. Never you come and cut from here, please. Okay, I've seen students do on mathematical things. So this times this will give us 1 squared, which is 1, plus this times this, cos theta, then this times 1, plus sine theta, plus sine times cos, sine theta, cos theta. Sine theta times cos theta, sine theta cos theta. Okay, all over sine theta into bracket 1 plus cos theta. Now, what do we do from here? Looking at this, we can, from here, you know that sine theta, okay. This takes care of this, this. So from here, we can think of what we can do, okay? Let's bring this guy and this guy together. We bring them together. I'll bring this guy and this guy together. That becomes sine squared theta plus sine theta. Sine squared theta plus sine theta plus 1 plus cos theta plus sine theta cos theta. Okay? So from here, cos theta is common here. We factor it out. Sine theta is common here. We factor it out. It doesn't really help much. What will help? What will help here? If we have, let's factor that out first. You know that this is, so let's solve the numerator only, So this becomes sine theta plus cos theta. Sine theta cos theta. 1 times 1 squared, 1 times this cos theta. Sine times this sine theta. This times this. No mistake there. So here we factor out sine theta into bracket sine theta plus 1. Okay, let's see if it works. If it helps in any way. Then plus 1 into bracket 1 plus rather, we factor out cos theta into bracket 1 plus 1 plus sine theta. Okay, so from what you can see here, you will notice that sine theta plus 1 plus sine theta are the same, right? So we can bring them together that sine theta into bracket 1 plus sine theta plus cos theta into bracket 1 plus sine theta, then plus 1. I brought this one outside there. So if that be the case, you will find out that this is common. So that is 1 plus sine theta is common between sine theta and cos theta. Does this help? Plus 1. Does this help in any way? Okay. Let's see if something can go out already. You know that this is 2. 1 plus 1, that's 2. Okay. So 2 plus sine theta. We have 2 plus sine theta into bracket sine theta plus cos theta. So from here, can we have, if we multiply this, let me pause it and redo it, please. Okay, I think I found what we'll do. I think we are still right on track. Let's simply open the bracket. This time this becomes sine squared theta plus this times this sine theta cos theta. We are dealing with only the numerator still. Now remember that sine squared theta is 1 minus cos squared theta. So this becomes 2 plus 1 minus cos squared theta plus sine theta cos theta. So from here, we can rearrange it such that we have 3 plus sine theta cos theta minus cos squared theta, such that we have cosine is common, so we have sine plus cos theta. Sine minus cos theta. Sine theta minus cos theta. No. I thought I found it just now. All right, please. Whenever you are stuck with a question like that, always check your question again. I wrote the wrong question. I think when I was transferring it up here, I wrote the wrong thing. Okay, I guess I'm hungry. There's 1 plus cos theta here. Okay, so at the LCD we'll have sine theta into bracket 1 plus cos theta. Don't worry, we'll not get stuck again now. So if this is the case, this in this remains this times this, sine squared theta plus this in this cancels, remain this. So we have 1 plus cos theta times 1 plus cos theta. It's times in itself now. So very easy. We have sine squared theta plus 1 times 1 plus cos theta plus cos theta plus cos squared theta all over sine theta 1 plus cos theta. So from here, we'll have that sine squared theta plus cos squared theta plus 1. You know, I've already collected this, and then plus 1 plus cos theta, 2 cos thetas, right? All over sine theta into bracket 1 plus cos theta. So from here, sine theta plus cos theta is 1. So we have 1 plus 1, that is 2, plus 2 cos theta. Okay, so from here I have 2 plus, so let's solve the numerator alone now. The numerator alone becomes 1 plus 1, 2 plus 2 cos theta. Okay, this one cannot go any further. Let's see, over, what are we reducing to? To 2 cosec theta, okay. That is sine theta. The question is not hard though, at all. Okay, we can factor out 2. Let's factorize 2 here. 2 into bracket 1 plus here cos theta. Yes, 1 plus cos theta 2 times. Yes. So you can see already that we have gotten our answer. Sine theta over 1 plus cos theta. So this can take care of this. So we have 2 over sine theta. That is 2 times 1 over sine theta. That is 2 times, what is 1 over sine theta? Cosec theta. So the answer is 2 cosec theta, QED. Now, do well to subscribe to the channel and let me know if you want me to shoot a long video where I'll talk about 20 things or 15 things that you need to know about trigonometry. And 15 things, yes. I'll list them now. I'll list them after the session. If you want me to shoot a longer version where I'll talk about everything you need to know, how to plot the graphs, or how to be able to tell what graph, or answer questions, and many things, proving those trigs, identity, converting sum to product to sum, you know, there are many things I skipped, okay? All the triangles, the types of measurement, degrees, conversion of degrees to minutes. Minute is the sexagesimal or centesimal system. Those systems of measuring angles, radians, and what they mean. Do you understand? Those things that you think you have to cram before you know. I'll teach you how to identify them. And then special angles. I thought I was going to be able to treat special angles, but they might soon withdraw power now. So I'm just going to stop here. Do well to subscribe to the channel. God bless you. And share the video with your friend. God bless you.